Okay, so let's get started. So far, what we have seen is we have seen how the mining Bitcoin, what are the key steps that happen in the Bitcoin mining, like how to check whether the hash value uh, found by the miner satisfies the hash difficulty requirements and things like that. So these are the important checks which the miners will do. All the miners will verify and things like that. Now let us focus more on the hardware part. What type of hardware infrastructure is being used for mining and things like that. So before going further, let me remind you about this Chikut Pass, which it's called the Gold Rush, Klondike Gold Rush, which is so here is the story, right? So in during the 1890s, so that is early 1900 and things like that, and this was in Canada. People found gold in the Chikut Pass mountains. So in those days, this is 130 years back, right? And the news spread a lot during the west coast of the US. So, for example, California, San Francisco, and things like that. And people actually lined up to go there, and because you can easily get the gold. So by using with minimal digging and things like that, so there was a big, huge rush. Unfortunately, the Chiku path is very, very complicated, very, very severe weather conditions. You can see here a lot of snow and mountains and things like that. So there was a huge gold rush. Out of all the people went, only few people got the gold. Many of them that died and things like that, right? So that was a good example about Bitcoin mining, saying that a lot of people try to mine blocks, but only very few are successful and things like that. Let us go further. So first of all, let's try to understand what is the difficulty in mining a block. All right. So first of all, it's used as a SHA-256 algorithm. As I told you before, SHA-256 is a pretty simple algorithm which can be generated on the laptop and things like that, right? So it is published in 2001 by the NASA and NSA, National Security Agency in USA, and then so this is what exactly how we compute the hash value in the CPU mining. So you can run this piece of code. So basically we are trying to increment the nonce. So this is a C++ code. So you increment the nonce. And remember, I was mentioning that we compute double hash. So we compute the double hash of the header. And if the double hash of the header is less than this threshold value, and then we get a hit for the puzzle, right? So it keep on, and remember, you can see here while true, this is an infinite loop, so it will keep on trying to find this hash difficulty within certain threshold limit. So this is the 56-bit computation. But on the other hand, so if you use your laptop to mine with the current difficulty, so for example, even if you get a very high-end PC, let's talk about a server, right? So even if a very high-end server, you get it will be in the 2 to the power of 24 things. But the time it takes to find a block or mine a block or find a block, it will take us 140,000 years. Remember, you have to produce a block within 10 minutes, right? Even if you produce a block in 10 minutes, then it is probabilistic in the nature that you might not be guaranteed, because let's say that you are competing with other miners, and if there are 2 blocks, and then you have a 50% probability that your block will be accepted by the miners, right? So, but if you use our computer or server, big server, it takes 140,000 years, so it's completely impractical to use CPU mining for Bitcoin, CPUs for Bitcoin mining. But the one, as I mentioned many times, one of the main design ideas behind the 32-bit integer, 32-bit hash value is that uh, the Bitcoin should have been mined by a CPU, normal computers and things like that. But the popularity and the craze for mining and the competition for mining, it has made things quite severe. Let's look into that a bit, right? So this is like a CPU mining is like the Chikut Maya pass where people try to search for gold, and but uh, the stash story. So then people quickly move to GPU mining. Then they can see that they can mine Bitcoins, and then the Bitcoin value also keep on increasing slowly day by day. So GPUs were used as part of the mining. GPUs, they are highly designed for high performance graphics. So in computers, we use them for rendering the graphics because you need to boot the operating system and load the graphics as fast as possible. Especially this is quite useful in gaming. And if you if you play video games, the graphics of high quality and high moving graphics, they have to be you need to have a high computation power. So GPUs will play a backbone for that. They're quite popular for high parallelism and high throughput. And around 2010, people started using GPUs for mining. And then there are a couple of the libraries you can use. For example, last year I was teaching a course on GPU programming, and you could use CUDA. CUDA is CUDA GPUs. If you want to program CUDA GPUs, you can use iCUDA, so the Python version of the CUDA and things like that. But most of the language the GPUs understand is C++. Whatever you do, even Python or whatever the language, the kernel function should be written in the C++ and things like that. So they are quite heavily optimized for parallel arithmetic operations. So that's why they have been successful, or at least a bit useful in the beginning years. So the but again, they have some disadvantages. Very pure utilization of the hardware, and poor, poor cooling, and large power drop. So they consume a huge amount of power, and you can hold each CPU can only few multiple GPUs and things like that. But the throughput is much better. You can see here it is thousand times much better than the GPUs, right? So now you can use GPUs. It is thousand times better than the CPUs. So now we have a better chance of getting a block. But even then, using 100 GPU cards, let's say we put it for mining, and it still takes 173 years to find a block with the given computing power, right? So why it is taking so much time? Of course, we have GPUs have a very high processing power, right? But my question is why it takes 170 years? Anyone? You can put in the chat, or you can unmute your microphone. I just want to see whether you are here or already left the class. Why it is taking so much time to compute a block, even with high-powered GPUs, 100 GPU cards and things like that? Due to high randomness? Yeah, but again, remember when we are discussing about when we are discussing about the hash difficulty, remember how many trillions and trillions times you have to um, try to get to this get to this hash value with the predefined thresholds, right? So for example, if we say that the first 17 zeros the first 17 digits in the hash value should be zeros, you have to try several trillion times, right? So that is the biggest number of times you have to try. And using GPUs, then it takes 173 times. Yes, due to high hash difficulty. Right. For example, if I specify, I have also shown you an example in PyCharm, right? If I specify that hash difficulty is 24 bits, then you could see that my computer could able to solve in few seconds, right? What does it mean? So if I specify that the hash value should start with first 6 digits of the hash value should start with zeros, that difficulty my computer can solve in few seconds. But if you keep on increasing the hash difficulty, then it needs to try many times, million times and billion times and trillion times and trillions times. So that's why it is taking so much time. Thank you for answering the question. So, and then people realize that the GPU is not a suitable thing because it's competition, right? Everybody wants to get more Bitcoins. So what you do, you go and buy very fast software. So people started buying GPUs. So that's why the GPU company shares was quite highly, they increased very sharply. NVIDIA could able to make so much money because now the GPUs are used for mining. So there is already a big demand for GPUs and things like that. But then people realize that GPUs, the competition is growing, so they need much better than GPUs. So they went for FPGAs. FPGA is typical software, typical hardware, field programmable gateways, which are used for internet traffic. They used it around 2011. They have a specific language called Verilog, which is a hardware specific language to program them. High performance, much better than GPUs, better cooling and customization. So you can use multiple FPGAs controlled by one computer and things like that. But the disadvantage is they have huge power draw, or you can say power consumption, poor optimization for 32-bit cards, and then very expensive than GPUs. And the amount of performance gain you got is very marginal. Even with the FPGAs, now you can see we are in the 2 to the power of 30. So that means they are 1,000 times faster than the GPUs in terms of the computing power. But even then, it takes 25 years to find a block with 100 ports, right? So then, which is also not feasible. And then people went with ASIC. ASIC is nothing but the special purpose hardware, which is mainly built for Bitcoin mining. So basically what it does is it doesn't have any kind of CPU kind of analytical power and things like that. It knows only one thing. It tries to compute this hash value, right? So they are mainly specially made for these purposes. Special purpose, but they are much faster than the FPGAs and things like that. They are designed to run constantly for life, and perhaps this is the fastest chip development ever had made in the history of the human race, right? Like normally the chip development takes several years, or you can say several decades over the mature and things like that. But I think this is one of the very fastest in the chip development. There were huge demand for ASICs because Terraminer 4 was one of the ASIC people used for Bitcoin mining. And then it is not sufficient that you just buy one Terraminer or something like that, one ASIC mine the Bitcoin and things like that. Because the computing power, the competition between Bitcoin mining is so huge. So you need to buy a rack of the ASICs, and you need to maintain a server farm kind of thing, right? So that means you are consuming a huge amount of power energy. You need to look for a place where the energy is cheaper and also cool climate, because then you don't spend a lot of time in air conditioning and things like that, because these machines, they generate huge amount of heat as well, right? So you can watch this good introduction to Bitcoin mining and how it is actually visiting a Bitcoin farm, mining farm, and things like that. So, if we compare with the evolution of hardware in the Bitcoin mining, people started with CPU mining. These are like initial days in the mining where people use small tools to dig for mine, right? So they dig earth and then filter things like that in the gold mining. GPUs like using Sluice Box, a bit more tools, a bigger tools, and FPGAs like is a placer mining. That means you will use some sort of the tools and other things. But ASICs is like bit mining, where you use big machinery to dig huge mines so that you can build mining. So it is compared to this kind of gold rush, because you can see how Bitcoin, even though initially Bitcoin started with a good design goal of using small computers for mining, but you can see that the craze for the Bitcoin, or you can say the craze for the profitability in the Bitcoin and things like that, it attracted so many people. So now it is the mining is not beyond the human reach, you can say, or ordinary people's reach. So only big companies with huge investments, they can mine the Bitcoin. Let us look into the power consumption of the Bitcoin. This is one of the biggest topics always people will talk about, saying that Bitcoin is spending huge amounts of energy. That's true, no doubt about it. To compare the how much energy Bitcoin consumes for the mining, let us take some examples about the energy comparison, right? So, for example, Tehri hydropower plant in northern part of India, it produces around 2,400 megawatts, and the Three Gorges River, which is the largest dam in China, or you can say the largest hydropower plant across the whole world, is it generates 10,000 megawatts. And a nuclear power plant normally generates to 7,000 megawatts, and the coal plant, it will generate around 2,000 megawatts. And this is again in 2021, Bitcoin mining consumes about 10,000 megawatts, so the equivalent to what the amount of energy that is generated by the Gorges River. Let's also compare a bit more. I think this is from the New York Times. So in 2009, you can see that you can easily mine the Bitcoin using your personal computer, right? At that time, the energy requirement, the electricity required for Bitcoin mining is like a few seconds of the household electricity worth, right? So if you are using your home electricity connection for mining, then it is a few seconds energy consumption. This was in the 2009. And today, again, this is from 2021. So you can see that you need a full room full of specialized software, these ASICs, which I was talking about. The amount of power consumption is the amount of household energy required is 9 years worth. So that means, let's try to understand this one. So if you want to generate one block, you will spend 9 years of energy consumption for a household. What does it mean? So all the energy you consumed in 9 years, you try to spend it in 10 minutes to make a block. So the electricity bill for the household for these 9 years is around 12,500, right? So the energy consumption, and the Bitcoin price was 50,000, so it was profitable. Again, remember that you cannot just only have few ASICs and try to make block, but you need to have significantly larger amounts of ASICs and pull them together to do mining. So the energy consumption keep on going. So people also compare the energy consumption between Bitcoin with the country's consumption. For example, it crossed Denmark and Finland and Sweden and things like that. Now it is reaching to a very high threshold. So you can see here, for example, it is consuming 4% of the total energy consumed by the United States. And it crossed many countries. So, for example, Czech Republic, now the Bitcoin consumes 3 times than what is the energy consumed by the whole Czech Republic, right? So that is the state of efforts in the energy consumption. Again, let us imagine where is this energy going on? It's just trying to find one stupid the hash value satisfying the requirements, right? So we try trillions and trillions of times to find this hash value, but in the end, it's completely mere waste, right? Because we are competing with other people, and we want to make the block and things like that. So in that sense, you are really sorry. In that sense, you are really trying trillions and trillions of times with a hope that you will get this hash value satisfying to these requirements. So there was also some arguments, people saying that Bitcoin is consuming huge amount of energy, wasting, so it is environmentally unfriendly, and it is contributing to the carbon emissions and things like that. But on the other hand, people will also have some people also support Bitcoin energy consumption by saying that how much energy is actually spent to maintain the fiat currencies. Fiat currencies has to be printed somewhere, and they have to be transported to ATM machines and things like that. If you combine all the energy consumption, people argue that fiat currencies have much more higher energy consumption than the cryptocurrencies. Again, these are some of the arguments, and yeah. Now let us look into the mining pool. Why mining pool? As I was telling you before, if you want to do Bitcoin mining, you need huge investment. You don't have that investment, right? So then what people will do is they will come pull up to resources and mine in terms of a pooling, right? So that is what happening now. So remember, Terraminer costs around $6,000, then it takes a huge amount of time to mine and things like that. So, for example, let's look into the mining uncertainty. Let's say that the probability of, let's say that you have few ASICs, you bought few ASICs, and you put it at your home and started mining, right? If you start mining for the whole year, the probability of finding one block is around 40%, right? Again, if you need to have a few hundred ASICs and things like that, then the probability of finding one block is 30%, and probability of finding 0 blocks is 42%. That means you are left with no blocks and things like that. But the probability of finding 3 or plus more blocks is 5%. So the chance of making blocks, if you work on your own, is very, very less. So it significantly decreases with the computing power and time taken and things like that. So this is just like throwing a lottery, right? Because you don't know. You spend so much money, but in the end you don't make any blocks, then you don't get any rewards, then you are doomed, right? So here is the idea. People can combine their the computing powers, so and form a pool so that they can combine all their computing power to make work on the same block. And if they're able to make a block, then they can distribute the revenue on the block. So that is the main idea. Distribute the revenues to the members based on how much work they have done. So, and then the pooling manager will take a cut on it and things like that. So this idea works like this. Okay, one of the main challenges here is how do we know that which members have worked? Because some of the members, let's say that you're part of the pool, anyhow, if you are getting equal amount of money, and you will get money whether you work for making the block or not, right? So you might have this free rider problem. So that means how do we find who has worked and who didn't work and things like that. So here are some examples. Let's say that we assign it to all the pooling participants a block, and we create a and then ask them to do. So let's say that out of several participants, let's say we have 25 participants, and what participant is lucky, this is the block which we able to find the hash value for, right? And then rest of the participants, they were approximately near, but they were not successful, but they were approximately near. If you say that, okay, we will only give money to the participant who actually found the hash value, then what happens to all others who try to solve this puzzle? You need to give some compensation, otherwise it is like trying to find a block on your own, right? So what people will do is they will distribute it to different they will prepare the block, the pool manager, all of distribute it to different people, all of them they work on the same block, so that they can try to find the value, right? So they put the coin value and the things like that, and then the pool manager distribute the block to each everyone, and then they try to do the number of hashes trials and stuff like that. Let's say that if the block is successful and it was found successfully, for example, let's say that this hash value satisfies the requirement, and then the money will be distributed in the form of in the proportional to amount of work they have done. So for that they have to produce the hash values they have found and things like that. So there are some mechanisms you can do it. So there are different variations. Even now there are a lot of tools where you can join your computing power to do Bitcoin mining. And some pools they work for pay for share. They have a flat reward and things like that, proportional to the work you have shown and things like that. And then look your approach. So that means there is only you will get money if you find a hash. And yeah, so there are different strategies to distribute the money. And one last step about the mining pools. So let's say that mining pools now became the more dominant. It is proper to say that Bitcoin mining is now completely done by the mining pools. Not ordinary people are participating in the mining pools because of this huge computing requirement and the competition, and the chance of getting the block is very, very remote, right? So that's why you can see all the mining pools. You have some big mining pools which control 30%, 40% of the mining computing power and things like that. And remember, one of the main design goals for the Bitcoin is to decentralize. And see what happened? Somehow we started with the decentralization where people started their mining and things like that. But see where we are heading. We try to avoid banks and other financial institutions, but now we can see this concentration of mining power into around few entities. So for example, Foundry US is controlling 30% of the mining power, and Antpool 20% and things like that. It was a bit Fury. I don't know, now they changed their name and things like that. So it was in the Georgia or Russian state or something like that. And one more comparison. So again, Bitcoin got a lot of popularity, and it also became 1 trillion market capitalization. And the cryptocurrencies reached 1 trillion market capitalization. And if you compare with the other companies, how much time for them to become 1 trillion? So for example, Microsoft, it took 44 years for them to reach this 1 trillion market capitalization. And for Apple, 42 years, because both of them, they were established at the same time. Amazon, 24 years, based on the computing services and stuff like that. Google, 21 years. They were search engine specialists and things like that. But on the other hand, you can see that Bitcoin actually reached to 1 trillion market capitalization within 12 years or something like that. Again, all these companies, they have professional managers and professional people, they have a systematic methodology working and things like that, and they have a strategy for investments and company growth and other kinds of things. But Bitcoin is a decentralized system. Of course, you have the mining pools and things like that, but on the other hand, it is driven by the people and things like that, right? So that is one interesting phenomena you can see. Of course, you can, this is a pretty good video explaining about a lot of concepts about the Bitcoin mine. I'm not going to run it because we also need to cover the anonymity lecture and things like that. But I would advise you to watch this one later time. Okay, so let's, any questions or comments before closing the mining session? Do you think the mining is sustainable, the Bitcoin mining? Is mining considered as a profession? Thank you for the question. Yes, it's a profession. It's not really a profession. There are many dedicated companies who are doing mining. Of course, let me answer like this, right? People were initially interested about mining, and then they started putting into mining. And you can see here, even though, let me answer like this, right? Maybe in around 2016, 15, around that time, you could able to, as an individual, you could able to mine the cryptocurrencies and make some decent amount of money. That is, so you buy some big computers and things like that. Maybe you can buy also buy GPUs and stuff like that. But you can see here in the last 5 to 6 years, the mining concentration has been around big companies only. So that means people who were previously mining in 2015 and stuff like that, now they can't mine because your computing power is not sufficient, and the chance of making a block is very, very remote. So you will spend years of, for example, you will mine for the whole year and you didn't get any block, right? So if you are not lucky, then you have no luck with the block, and then you're completely wasted all the money spending and things like that. But now people are joining the pools. So you can say that it's a profession if you know how cryptocurrencies are working and how to ride the tide and things like that. What does it mean? Sometimes people will who are actively participate in cryptocurrencies, they will also mine different currencies, right? So sometimes they mine Ethereum, which is very definitive and maybe not that profitable, and then they switch to Bitcoin sometimes and stuff like that. They multiple. But again, the mining, how do? They will simply go for the join the mine pools. Is it require heavy funding to start? Yes, you will need at least I'm not expert on this. At least few million, for example, $50 million or something like that, or $100 million. Maybe it's exaggerated, but you need millions of dollars to invest the mining equipment, because you can buy ASICs. ASIC is $66,000 or $10,000, right? You can easily buy 100 ASICs and you can start mining. But on the other hand, the chance of making a block is very, very less, because you are competing with these big mining pools who have huge amount of computing power. So if you want to compete with them, then you also need to make a huge investment. So that is where actually it is depriving. That's what I was always a bit sad about how things went in the Bitcoin. It started with a good design principles of commonality and other kinds of things, but on the other hand, we can see that how it evolved over the years, just like the banks, right? So if you want to start a bank, then probably you need to have a huge amount of investment. Like that, mining is also became monopoly in the hands of few people, few organizations, and things like that. Yeah, so it requires heavy funding to start with and some luck. Yeah, the luck always plays, but the luck is like just buying a lottery ticket. So that is what happening. And of course, it's much better than buying a lottery ticket because you know what is your odds, right? So the way to compute is, let's say that you think rationally. You will look into the hash rate. Hash rate is the total computing power in the network, and you will compute. You will take the proportion of your computing power, your hash power, with the total hash rate, and then you will see that it is less than 0.1% or something like that, and then that is the chances of getting a block made by you, right? So that's why it's a lot of people moved away from mining, and then yeah, they join mining pools now you can join a mining pool. So there are still online mining pools. You can join them, and you can use your computer to do mining, right? So but the chances of winning money is very, very less, of course. Yeah, but you also need to pay your bills because you are running your computers continuously and things like that. Okay, any other questions? Okay, so then let us maybe take a 10 minutes quick break, and then we will get done with this and what you call anonymity lecture, right? So I have a few slides, and I will also talk about Tor browser and things like that. So let's take 10 minutes break.